Hey guys, today we are going to talk about greatest common factor. So this should be a teeny bit of a review. Like you should know what greatest common factor is. But I'm actually going to show you how to use the cake and the trees to find it much faster than the way you've learned in the past. So to get your brain started on what we are doing, I would like you to get out your notebook, pause the video, and complete this warm-up. I would like you to list the factors and the prime factorization of both 24 and 30. Okay, so doing that right now for me, pause the video and try this on your own. Okay, so hopefully you paused the video and you found both the factors and the prime factorization of each number. So the factors of 24 would be 1, 2, 3, 4, 6, 8, 12, and 24. So those are all of the numbers that multiply to give us 24. And then the prime factorization would be 2 times 2 times 2 times 3. Okay. And then for 30, the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And then the prime factorization is 2 times 3 times 5. So hopefully you did well on that. You need to know kind of both of those skills to know what we're doing today. So you should have your math notebook out, your calculator out, and a pencil ready to take notes. So greatest common factor. Greatest common factor, the definition is kind of in the name. So if I were to ask you to find the greatest common factor of 12 and 10, what does that mean? So you are looking for the largest number or factor that evenly divides into both numbers. So the largest factor that they both have in common, the greatest common factor. Okay, so the definition is right there in the name of what you're looking for, and then I'm going to show you the way you learned it, hopefully last year. So if I'm looking for the greatest common factor of 12 and 18, last year I am hoping that you were just taught to go and list all the factors. So factors of 12, 1 and 12, 2 and 6, 3 and 4. Then you have the factors of 18. So 1 and 18, 2 and 9, 3 and 6, and that is all. Okay, so then after that, you want to look for all of the numbers they have in common. 1 in common, 2 in common, 3 in common, 6 in common. The greatest common factor is the greatest number or greatest factor they have in common, which would be 12. So the greatest common factor equals, the greatest common factor is 6, the greatest factor that they have in common. So this method is totally fine. Like if you want to move forward using this, great, go for it. I was never a fan of this because one, I sometimes forgot factors in my list. I was very good at forgetting a factor. 2, as the numbers get bigger in 6th grade, like we're not going to just do 12 and 18, and we're going to do larger numbers. They're going to have a really long list of factors. So you could be listing factors for quite some time until you get to you figure out the greatest one they have in common. So you can actually use the cake and the tree method to find the greatest common factor, and I'm going to show you those next. So I'm going to show you both. If you chose the tree method, on Friday and yesterday, you can move forward with that method. That's fine. It's a little bit more complicated than the cake, so maybe check out the cake. But if you chose the cake method, you can kind of just zone me out during the tree example. You don't need to know how to do that. You just need to know how to do the cake. So I'm going to start with the tree in case anyone here wants to do the tree. So if we're trying to find the greatest common factor of 12 and 18, I want you to make your factor trees for both 12 and 18 to find the prime factorization. So I want you to write that down, and then we'll do it together if you're doing this with me. So copying this down in your notebook. So 12 would break down into 2 times 6. 2 is prime. 6 breaks down into 2 times 3. 2 and 3 are prime, so I'm done that tree. So then I'm going to write down the prime factorization. 12 is 2 times 2 times 3. And then I'll go find it for 18. 18 is 2 times 9. 2 is prime. 9 is 3 times 3, which both of those are prime. So those are two very easy trees. So 18 equals 2 times 3 times 3. So whenever you are finding the greatest common factor with the trees, you want to look at the prime factors they have in common. So if I look at my list of prime factors, they have a 2 in common, so I write a 2. They also have a 3 in common, so I write a 3. They don't have anything else in common, so the greatest common factor would just be 2 times 3, which is 6. Greatest common factor is 6. Okay, so we found the prime factorization of each. Then we looked at what prime factors they had in common. They had a 2 in common and a 3 in common. So you just multiply those to get 6. Okay, so I will show you another example of that. Don't worry if you're doing the trees. If you're doing the cake, it's your time now. So before you just had half a cake. It was kind of like weird because you were eating only half of a cake. And who only wants half of a cake? We want a full cake. So today you're actually going to do the full cake. So you're going to start by writing, you're going to draw the first layer of cake and you're going to put 12 and 18 inside. So do that now in your notebooks for me. So I always like to write my list of prime factors so I don't forget them. Or prime numbers, my bad. Okay, so just like before, how you were seeing if it's divisible by 2, divisible by 3. You're going to do that same thing, but you need a number that both of these are divisible by. Okay, so it's going to go on the outside, it's very similar to the half cake, just one more number is included. So start with 2. Are 12 and 18 divisible by 2? They are both divisible by 2. Doesn't hurt to type them into the calculator and check, but you're going to write a 2 on the outside of that layer of cake because they are divisible by 2. And then in the next layer, we're actually going to go and divide. So 12 divided by 2 is 6. 18 divided by 2 is 9. So then keep seeing if it's divisible by 2. Are 6 and 9 divisible by 2? It's not, so we're going to move on. Are 6 and 9 divisible by 3? They are. So you put 3 on the outside. 6 divided by 3 is 2. 9 divided by 3 is 3. So 2 and 3 are both prime, so they're not going to have a common factor. When you get to the bottom of your cake and you can't find a prime factor of either of them, you're done. And the numbers outside your cake are going to be the greatest common factor. So 2 times 3 is 6. So your greatest common factor equals 6. Okay, so I'm going to show you another example of that. If you did not understand the first time, it is completely fine. But I do want you to make sure you have your method copied down so you have an example to look at, okay? So the cake is much easier. So if you're still hanging on to those trees, maybe think about going to the cake. Just a suggestion. Okay, so next we're going to do the greatest common factor of 18 and 36. So I'm going to do the trees first again. So if you're doing the cake, just hang tight. So 18 and 36 will make our trees for. Okay, start by splitting up 18. 2 times 9. 2 is prime. We did this last time, so this is pretty easy. 3 times 3 gets us 9. And don't forget to pull out your prime factorization. 18 equals 2 times 3 times 3. Okay, 36. So we're going to break down 36. And I know that 2 times 18 gets me 36. 2 is prime. Break down 18, but it's pretty easy because I already have that tree. 2 times 9 is 18. And 9 is 3 times 3. Okay, so 36 equals 2 times 2 times 3 times 3. Okay, so found the prime factorization of each, wrote them down. Notice they're stacked. It's much easier to find what's in common when they're stacked. So now you go and circle what they have in common. So they have a 2 in common, so you write 1, 2. They have a 3 in common, so you write a 3. And they also have another 3 in common, so they have another 3. Notice for every pair that you circled, you should have a digit. So 3 circles, 3 digits, and then you're going to multiply them. 2 times 3 is 6. 6 times 3 is 18. So our greatest common factor is 18. Okay, so all of you using the cake method, you're up. So first layer of cake, 18, 36. Write it down. Don't forget your prime factor list. Okay, so 18 and 36. Are they divisible by 2? You bet they're divisible by 2. So then we're going to divide by 2, and that goes in our next layer of cake. 18 divided by 2 is 9. 36 divided by 2 is 18. So then are 9 and 18 divisible by 2? No. Are they divisible by 3? They are. So we put a 3 on the side, and then we divide. 9 divided by 3, 3. 18 divided by 3 is 6. So 3 and 6, are they divisible by 3? They are. So we're going to divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So 1 only has a factor of 1, and 2 only has a factor of 1 in itself, 2. So we cannot pull out another prime number, okay? So therefore, we are done our cake, and we look to the numbers on the side, and we multiply. 2 times 3 times 3. 18. So our greatest common factor equals 18. Okay, so make sure you copy those down if you haven't already. Okay, so I have 2 more examples for you. I would like you to try these on your own. I want you to pause, try them on your own, and then I'm going to show you the work. So try both of them. So you're first going to find the greatest common factor of 14 and 35, and then the greatest common factor of 148. So you should have 2 different problems that you're trying right now. I'm going to show you my work with the cake just because that is the one I want you to try to use, because I promise it's easier. But if you're doing the trees, you should still get the same answer. And if you want to just list the factors, because that's what you like and that's what you know, go for it. I'm definitely not going to stop you from doing that. When we get into least common multiple, it's going to get a little harder, and the trees and the cake will help, but I won't stop you from doing a method that you know and like to do. So just go for it if you like it. So at this point, I want you to pause and try both of these, and then come back to check your answers. Okay, so hopefully you try both of them on your own. If not, shame on you. So here are the answers that I got. So the greatest common factor of 14 and 35 was actually 7. And then the greatest common factor of 148 was 4. Okay. So hopefully looking at my cake, you can kind of compare it to yours and see what you did correct, maybe what you have to fix, but it's up to you to look at my work and try to figure out where you went wrong. If you need help, if you really don't understand this, if you maybe just want to see 1 or 2 more examples, I want you to join my Google Meet at 11:30. I'm there to help you, and I cannot help you if you do not join. So please, please, please come and do problems with me. Okay? So your only other assignment today is to complete the formative to practice, and then tomorrow I will have you practicing more greatest common factor, just so I make sure you know what you're doing. Okay? So have a great day. Don't forget to do your homework.